Hi Nirant. Hey Priyank.
Hey, Ayush, thanks for doing this when you're sick.
Yeah, I just didn't wanted to change the plans last minute. I thought I'll be better by today, but unfortunately not. So yeah.
Yeah, so folks, Ayush is down with viral fever, but he is here with us. So, I'll do a quick intro. So we have Nirant. Nirant is I'm a big fan of Nirant. Nirant runs the generative AI community in Bangalore. His WhatsApp group is very popular. I should say he's the principal headmaster of the generative AI groups in Bangalore, but he's definitely a very knowledgeable and super connected in the ecosystem, both in India and abroad, and expert in his own right among a large number of topics. So, and he'll be leading our discussion on VectorDBs. That is the first talk. And then we have Ayush. Ayush is I should say, serial entrepreneur. This is his second startup, and they are saying doing something amazing at Portkey, which I would recommend all of you to read about. We were initially planned. They also have come up with something very interesting in Portkey, which is actually the first product they've launched is I should say prompt ops. Ayush, you can correct me if I'm wrong. I don't know whether that term has been invented yet or not. But that's the first thing. And then they have also launched something which I found very interesting, which is semantic caching, which I think we'll have Ayush over once again in one of the webinars to talk about. Essentially speeds up your LLM apps and reduces cost as well. So thank you both of you for joining. And then Nirant, maybe you can take over and we can start. We'll just, for the sake of time, we'll start on time and we'll end on time. So thank you. And I'll switch off my video. Just one aside, folks, please feel free to ask your questions. You have any, let me see if I can enable. Okay, I'll check if however I switch on so you can ask questions on the Q&A box, as well as I'll figure out a way. I think the chat is somehow not enabled. I'll enable the chat as well. Yeah, I've enabled the chat for everybody. So you can start introducing yourself on the chat if you want, and you can chat with all the attendees as well. We have 40 plus folks now, so we can start the discussion also. So Nirant, all yours.
Hello, we're going to talk about vector databases, and I really speak fast, so please interrupt and ask questions. I think in this Zoom setup, we can do the Zoom chat thingy. I have that on my right pane, so if at the moment you post a question, I should see that. So you can ask it as you go. I don't see the chat, but I can see the Q&A, so you can post there as we go along. What we'll talk about is why do we need vector databases? Roughly 1/3 of the people who fill the form registered for this are people who are interacting with those for the first time, and hence that question. We'll look at a few use cases, including the hero use case, which is building your own GPT on your own data. And we'll also consider how to choose a vector database. If we are left with time, we'll also try to answer the question of how do we evaluate embeddings, how do we evaluate retrieval augmented generation systems, and some tricks, tips for retrieval and chunking, which go hand in hand. Cool. Yeah, Axel said that they will share the recording of this event. So yeah, that should be done. That's from the Q&A. Quick about me. I've been a machine learning engineer for quite a bit. I mostly have focused on language processing for a bit. This is my QR. In case you have a phone near you, this will take you to a Google search of my name. Right now, I mostly do consulting. That is also apparently called LLM Studios in SF. I learned this Sunday. So I'm going to call it an LLM Studio because it sounds fancy. Okay, moving on. Why vector databases? The first part of this question, the first part of this answer is I'll try to answer it from the lens of use cases and new experiences with this unlock. So most popular use case before 2019, before 2020 for vector databases used to be recommendation systems. In fact, bulk of the work at that time used to be come from teams interested in field ranking and similar problems. So as an example, Spotify built Annoy, and Facebook has a very popular library called Fest. So both of these are very popular implementations, and they're still quite actively supported. Spotify's most recent release is from 2022, if I remember correctly, but still there's some development around them. What do I mean by RAG, or retrieval augmented generation? Hence the title of the talk, RAGs to riches. You can see that in the footnote also. That is basically every time we try to build a system which works with your data, which is ChatGPT on your data, is what we will call that RAG. Um, for the link to this, these slides, you don't need to record anything or something. That's on the footnote as well. You can find that here in niransky.com/awesome-vectordb. This is what a very common outline, a very simplified outline of a retrieval augmented generation system looks like. So while this system allows you to answer questions based on your documents, it's also the opposite of, in many ways, it's opposite of the ChatGPT plugin. While the plugin is the idea that you take your document to GPT, this is the opposite idea that you let the data be where it is, and you take the LLM to it. The core steps are the offline or the ingest process is that you take a document, embed it, and store it in a vector database or whatever your choice of store. And when a user comes in, you embed it, look at the most nearest, most similar documents, pass it back to the language model, and that is the answer which goes to the user. This is quite often orchestrated via a popular library like LangChain, Llama Index, and more recently, Microsoft has a implementation called semantic kernel. So why do we even care about vector databases? So like, what are the challenges in working with vector databases? So one is these are some questions which you will come across if you use things like FES and NOI. I had put NOI in production 2018-19 and actually maintained the system for about 2 years. So I have some of those long-term consequences of maintaining a system problems. So one is how do I look up the payload? Payload is basically whatever is your text or document against an embedding. Latency, what time does it take to look up a nearest neighbor? Any sort of metadata which is around the daemon. So for instance, in a classical PostgreSQL insert, you could do things like insert ID, which is updated at the insert time or update time both. So updated at and inserted at become two columns, and you can just fill that in. In the SaaS context, you also care about things like which tenant created this and some sort of mapping like that. And you want metadata and payload to be close to the vector, and both of those put together is what you quite often call points. A point is a vector and a metadata put together. And all the common IO challenges why we don't use file systems and actually use a Postgres or a Mongo, which is partial read writes, concurrent read writes, guarantees that when you write something to the database, it will actually be written and available later. That is still present with vectors, and hence those they also continue with here, and that is why we need something better than a FAST or let's say NI. I will quickly jump to.
Sorry, Nirant, there is a
Yeah.
question from Ashish. Ashish, do you want to ask that question on the chat, please? Or I can bring you on stage and ask it. I think it's better if you type out your question on the chat window. Okay, Ashish asked the question, do the VectorDBs have support for updating docs in real time?
Depending on how you define real time, most of them do, yes. Assuming you define real time as, let's say, 10 milliseconds or less, almost all of the modern ones do, with some of them having longer write time. For instance, if I recall correctly, Chroma has a longer write time, so does Redis, especially if your payload is very large. But in all other cases, the write is quite fast. And obviously, the hard disk on the RAM on which you run or host this vector database also matters. But yeah, that's 10 milliseconds or less can be considered real time. Are
So
there more
just
questions?
just a quick clarification, Miran. The diagram was very self-explanatory. But let's say I have like a huge PDF or a Google Drive document, and it is being updated by multiple users, across whatever, right, over a period of time. So as people update that document, and on the same side, end users are doing semantic search queries on the vector store. So, or via the LLM served by the vector store. So is it are current platforms like Quadrant and BB8 and others and Chroma and all able to handle that in like with good latency?
So, yes. Quadrant, I know I have tried this with Quadrant where a team actually serves their FAQ via that. So I know that the customer support teams update that multiple times a day, and sometimes during a sale, they do it very, very often. So Quadrant, I know that it works because I know Vivet's design, I expect that to work as well. I have not had a chance to try any other one, to be transparent, but based on design, I also expect, let's say, PG Vector to work, which is a Postgres extension. So because Postgres has reasonably fast writes, so it should work unless you become read bound for some reason.
Okay, thank you.
Where were we? Huh. My favorite question. In fact, this was a question which was also asked on Twitter. Why can't we just use NumPy? Why do we need this? So two reasons, mainly. One is speed, latency, which we were just talking about. But the very first question is about real-time updates. So yes, concurrent read writes, again, depending on read bound versus write bound, that is dependent on this. This almost became a meme thanks to Kapathi's but yeah, but he was actually talking about this in the context of 11K vectors for a side project. And for that, yes, you should use NumPy because you can just pickle that file and it will be worth a few kilobytes at maximum. Just use NumPy. Yes, that probably sounds right. And just so that I don't have to say it again and again, 11K vectors do not have to map to 11K documents. Sometimes a single document could be worth 10 vectors, 100 vectors, or even 1,000 or 10,000 vectors, depending on how richly do you want to capture the detail of the document and how many segments do you divide that document or chunk it into before you embed it. And hence, for this deck, I've tried to qualify between docs and vectors. And in case I've made a mistake, I will try to correct it when I'm giving the talk right now. So speaking of NumPy, I decided I wanted to profile NumPy. And there is a very interesting thing that depending on how is your dimensions of your embedding, the performance changes quite a bit. For almost every 1 million embeddings, it adds 50 milliseconds of latency, and it's a linear scale. And this seems to hold all the way up to 3 mil in my experiments. But when I tried it for 1536, which is what your typical OpenAI embeddings are, you actually are left with 37 seconds. So this is roughly 37 seconds, the topmost orange bar at 5 million 5 million vectors. Sorry. And the most common alternative to that is the HNSW which is also a Python implementation. That is still a couple of milliseconds, not quite a lot. So yeah, and this is for a lot of documents, k is equals to 10. Most RAG systems will actually require k equals to 3 or like relatively smaller numbers. 10 is quite a lot and more popular in search and research than anywhere else. This slide should be mostly self-explanatory, but I will read it out anyway. All the way, I think between 1 and 5 million, you can use NumPy, PES, NY, whatever you want. The first two are mostly libraries in my mind. They're not really vector databases. They don't give you the guarantees of storage. They're not performant. Uh, and start breaking as your queries per second also increases. So tying it back to the earlier question which we had, is it real time? Most of these are not. So NI Chroma are not real time in the truest sense. you start getting near real-time performance from PG vector Redis onwards. Uh, Quadrant event, I know them to be real-time. Um, Unfortunately, while I know that a lot of the audience has used Pinecone, Pinecone legally prevents me from talking about them. So yeah, that's the trade-off there. I can pause here for questions, or in case people have questions, please keep posting them.
I think there is a question from Ashish again. Can you explain payload a little bit? Payload versus metadata. And while you
Yeah,
answer that, I think folks, you can raise your hands. I think it's better. We will just bring you onto the stage to ask that question personally.
yeah, that would be great. Thank you. Payload versus metadata. So payload is the image or text which you are, or whatever is your media which you want to query, which also has an embedding which you care about, which has the vector which you care about. And metadata is anything else which you want to store with it. So for instance, created at, when was it last updated? Any IDs, or let's say the tenant ID. All of the product business logic metadata in that sense is what I'm calling metadata. In the VectorDB jargon, like design systems in that sense, it's all called payload typically. But from a API lens, we sometimes call it, we want to differentiate it sometimes for on developers' own convenience when they're using them, and hence the two terms, which is payload and metadata. I hope I have answered your question, but if I have not, please follow, ask a follow-up. On where does Elasticsearch lie on this spectrum? We don't know. So Elasticsearch actually builds on Lucene, and for comparable hardware, um, it's very chaotic depending on the configuration and the size of your document. So yeah. Also, the Elasticsearch implementation, which is inheriting from Lucene, has not been that well tested. In fact, I don't know anybody who runs. I actually happen to know more people who run NOI systems in production than Elasticsearch with vectors, partially because it is so new, and partially because most people who do use Elasticsearch run that for BM25 and don't want to make that index very heavy for other users. So because of those two reasons, even people who would want to have not tried that.
All right. So I'll bring Dhruv online. He has a question. Dhruv, could you introduce yourself and probably switch on the video as well, so that it'll be just better for the speakers.
Sure. Can you guys see me?
Not yet, but go ahead, ask your question. Yeah.
Okay. Hey, so Nirant, I had a question around the costs involved. So I tried a few projects with LangChain with Pinecone, and even with like maybe around 100-ish docs with maybe like around 2000 plus words each doc. I encountered some, somewhat of high like costs with tokens, OpenAI APIs. So can you just maybe walk us through that a little bit, the costs involved in production?
I will do a deep dive on that a little later, but let me give a quick primer on how we think about cost, right? In terms of pure systems. Let me go back to the drag diagram. A second. Yeah. So you have two cost centers, right? One is your embedding. And openly embeddings have gotten cheaper in the last 2-3 weeks. Used to be more expensive. And the LLM calls themselves. So these are your two cost centers. There are no other real costs as such, unless there is a vector database which you are doing on cloud. So for instance, if you're doing it on with Pinecone, Pinecone charges you for storing a vector also. It is not based on usage, let's say, which is retrieval. Let's say S3 has an egress charge and a storage charge. In Pinecone, the storage charge dominates your usage charge. So it's very expensive because of that. Vespa.ai, where does it say? I have not had a chance to benchmark Vespa at all. So yeah, I can't really comment about it. I don't think. Does the vector size impact performance of a vector DB? Yes, this is what I was trying to say, that 256 versus 1536 dimensions, which is the size of the vector, make a lot of difference on the performance of the vector DB or whatever is your implementation. So this will always, and this will also have impact on the performance going forward. Like this will not change. This is one of those physics laws in that sense. If you have more information which you're searching through, unless you have an index which is richer, for some reason, you will always end up spending more time looking through that. So that is the indexing difference here. NumPy is by design O of n, and HNSW is O of log n. But even on a log linear scale, which is what you say here, this is the bottom axis is a log scale, while this is a linear scale. The y is a linear scale. It will have an impact. Dhruv, did I answer your question?
Yeah. I think that makes sense. Yeah. Any other kind of optimizations that we could do? So let's say I'm developing a basic project with LangChain and Pinecone. Can I maybe work through like maybe chunking strategies that could be different to optimize on cost? Like, can you maybe touch on that a little bit, or will you be talking about that later in your
Yeah,
presentation?
so we do have some dedicated time for retrieval augmented generation systems in particular, and how to improve those. Uh, but yeah, not a focus in the sense of that this was focused on vector databases. But if we want, we can skip ahead to that. I have no way
no,
to
I think,
tell.
sorry to interrupt, Nirant. I think maybe just continue the flow of your presentation, and everyone, I think it's better. My guess is that, let Nirant continue the flow of the presentation. You keep asking questions in the Q&A, so he knows what to cover, and he'll pick it up as the things come, and that'll be better, I think, for everyone.
Yep, sounds good. Yes, Ashish, the embeddings are independent of the vector database. Yeah, you can use OpenAI, Cohere, whatever you want, actually. I have been known to use Instructor Excel and MiniLM from Hugging Face quite often. So yeah, that's that. There. Okay, coming back to the deck. We see a lot of new models which have much larger context windows. And in addition, so the most common question is that why do vector databases still matter? So the answer is LLMs still tend to hallucinate. They might not have context of your own data at the moment. Updates. So if you want to ever update a LLM, most of LLMs are actually trained. So for instance, OpenAI, famously the 2021 cutoff. And it's very hard to augment that with your data or updating your own data with that. And cost, obviously, you don't want to dump all your data there. Cool. Vivek just shared that they use Elasticsearch for storing vectors and it's quite fast. Uh, I would love to hear numbers if you have any, like if you have a queries per second number or and any recall degradation number, that would be great. Vivek, I would love to hear that. Elasticsearch, why or why not? Actually, I would have personally loved to use Elastic. I've used Elastic since I started my career for text. So yeah, but as more and more work, let's say for instance, if you're building something like Civitai, or even if it's something which has any non-CDN components, and you want to work with images, any form of audio or video, Elasticsearch becomes a bottleneck because while it has an dedicated index for text, the vector index can have size limitations. Uh, this is more a case for why you would need vectors than why against Elasticsearch. So yeah, that's there. Um, Lucene also supports HNSW, so there is if that is what you want and you don't have, and if you're not storing, let's say, more than about 100K vectors, I guess you can use Elasticsearch and the AWS port, which I think also has inherited Lucene now. Sorry, also wrapped Lucene now, called OpenSearch. I will let's talk about the vector database from our API lens, because most of us are much better at understanding APIs than anything else. There are only 3 APIs, so it's pretty easy to understand. That is the insert. Insert is quite often in terms of points, and points are consistent of your media, which is, let's say, text, images, audio, video, whatever that is. And the vector itself, they both together make a point. Um, and the metadata, so for instance, inserted at, updated at. The second is the index itself. The indexing algorithm is a hierarchical graph-based algorithm which cuts your entire vector space into multiple small segments so that finding nearest neighbor becomes much faster. Most implementations today, including the open source, let's say the Rust implementation, which is Quadrant, uses HNSW as an algorithm for indexing. So does VV8, and to the best of my knowledge, Pinecone, which is also a Rust implementation or has Rust components, also uses HNSW for indexing. Yeah. Um, Search has more interesting behavior. So for instance, in addition to the index, you might want to support other forms of search, which is, let's say, text-based filtering, some keywords, or geospatial. Since we have a lot of people who do use Elasticsearch, barring geospatial use cases and, let's say, image search use cases, media search use case, sorry, this is a use case where Elastic might actually excel, and definitely does better than Lucene for obvious reasons. Uh, Next, we'll talk about 9 reasons or 9 considerations on what to think about when you select a vector database. Yeah, and yeah. So the first or the most common is developer time is still more expensive than most system. So we do care about the developer experience. As an example, VV8 has transformers, the embedding package built in. So you can use that to embed your stuff very, very easily via something called what they call modules, which makes that slightly easier to use. In contrast, systems, let's say like Quadrant, ask you to embed and make a point and then upload that point. Uh, if you are using Elasticsearch, OpenSearch, any of those things, then probably you want to continue using that. That makes a lot of sense. Uh, will the system be maintained and developed? If not already, you should see a bunch of vector databases coming in the few weeks, months, including some of which will be very well marketed. But they might not be around for very long for a mix of different reasons. So for instance, the one which I like to diss the most is Chroma. It is a wrapper around DuckDB. They don't have any engineers who have done DB engineering in the team, even several weeks, months after the launch. Exceptionally popular because of their SF DevRel work, exceptionally good at marketing. But we don't know how long it will be maintained or developed. Uh, Obviously, managed versus self-hosted. Dhruv had a question on cost. I'm willing to wager that anywhere between 20 and 40% of that cost is Pinecone, because managed DBs are quite often, managed vector DBs in particular, are quite often quite expensive. Uh, Performance. The most trusted benchmark is actually an external benchmark called benchmarks.com. It's maintained by the creator of NOI, who no longer has a vector database application, making him the best person to do this. In addition to this, obviously, every vector database company has their own benchmarks in which they obviously are the best. Yeah. Uh, I think we've discussed this. The motivation for management self-hosted is actually twofold: cost, and the other is in case you have a compliance reason for which you do not want to send the data outside your VPC, you will want to self-host quite often. Slightly more advanced considerations are: do you have some vector databases also support hybrid search support, which allows you to do hybrid indexing, which gives you a much better cost to scaling ratio in both developer terms and compute terms than, let's say, Elastic. This I know to be true because I know people who have tried Elastic and switched to the other ones, which support BM25. So that is quite an important consideration for people who have had a system for some time in production. Uh, some version of partitioning or multi-tenancy so that you can separate vectors logically. This is not always done physically, just to call it out. From top of my memory, Quadrant, VV8, Pinecone, the top 3 most popular ones, all have support for this built in. Less understood point, which is multiple vectors per point. What this means is, let's say you have a paragraph and you want to have 2 embeddings against it. One is, let's say, all the embeddings for the entities against it and the entire text against it. So that would be, you would want to be able to have, you would want to have the option to store multiple vectors per point. We have a question from Arvind Nagraj, which is there a known benchmark for hybrid queries? Say, for example, you want to filter for timestamp and only search in past days vectors. We use Milvus, and I'd like to know how others fare. So hybrid queries, different ways to do it. I actually wrote a tutorial on this. I happen to use Quadrant and Llama Index for that. I don't think this really depends on the vector database because it's a sort and filter kind of thing, depending on how you structure your operations. Yeah, another question from Ashish. User-centered query, how is that managed by faster when it becomes I will take that later, Ashish, later in the discussion when we talk about RAG in more detail. Yeah, we can leave that unanswered for now. Yes. So just another question on indexing large code base. Chroma is painful. Yes, yeah, that is why I don't like it and I openly diss it. You could use anything other than that. My top two recommendation would actually be, if you care about lookup speeds, it would probably be Quadrant or Pinecone, depending on what you can, how much you want to spend on it. And if you're caring more about developer experience, VB8 wins quite often actually. They have a very flexible class and schema definition, which is quite nice to use. So in that sense, it's quite good. Okay. Yeah, there's also a comparison between the three on the slide right now. There are other minor differences. So for instance, Pinecone does not, Pinecone only allows some KB of text data, while Quadrant allows all of JSON payload. VMware is also slightly more forgiving. So these are all design differences on how they have all implemented what and for the kind of customer they wanted to serve. I have also included for the sake of completion, PES, PG Vector, and Redis. I have tried to use Redis Cloud, and I got a $700 bill for about 4 MB worth of text embeddings, text plus embeddings. Embeddings for 4 MB, the text was larger. But yeah, since then I have stayed away from the cloud offering at least. But yeah, painful experience. So PG Vector is offered, also has cloud offerings via things like Superbase if you're trying it out. So yeah. Yeah, I think before we go into RAG, which is also the question which we've left unanswered, I can pause here for questions.
So folks, please type in your questions into the QA box. And Nirand, I had a question myself. So, you have Chroma. Is Chroma and Face like file system base versus others are actually like proper databases? Is that a key differentiator?
Chroma actually claims to be a different full database, but they're actually a file system, at least the way I look at it. So the line between file system and vector databases starts to blur once the vector database itself starts supporting some version of disk usage directly. So yeah, that way. But in practice, it's quite slow, and that is what matters. It's quite slow to write and it's quite slow to read from, which is the main use case for vector databases, that you should be able to do concurrent reads and writes and shouldn't have to wait like 100 seconds for indexing to happen, which is quite common with Chrome.
Thanks. And one other question from my end, which is like, what exactly is hybrid search, right? So how do you do hybrid search? Like, is it first you do textual search and then you do vector search? Like, how do you actually get to the correct answer in hybrid search? What's the methodology?
So hybrid search actually is very open-ended as an idea. There are at least 2 or 3 implementations. The simplest and the most popular is what you just mentioned, that you first, let's say you have 1 million documents, you first use something like BM25 or even TF-IDF to select, let's say, top 1,000 documents. And on those top 1,000 documents, you do embedding search because that will still be quite fast. That is the most common way of doing hybrid search in practice. The other way is that you combine sparse embeddings and dense embeddings, which is a fancy way of saying that you combine a document representation based on the tokens and sparse embedding, which is zeros and ones, and the dense vector, which is your embedding into the same space, and then you do a nearest neighbor lookup on that, which is where the multiple vectors per point idea also comes to be handy. They're both useful in certain contexts. So for instance, in text, I've seen the simpler approach work quite often quite better. In case of, let's say when you're doing any form of video search or any text which has structured information. So for instance, there's a title which you want to query differently from the body. Then you want to start thinking about being able to have both the embeddings in the same point. This is also known as splayed in some contexts. Um, yeah, that's the two most popular ways in which hybrid search is done. The third part of it is also what we had a question around that. Let's say if you had some other metadata which you want to filter on, so for instance, whatever has been updated in last 24 hours. This is what we Llama Index calls it second pass retriever or something, second stage retriever. LangChain does not really have a good way to do this right now, any sort of metadata operations, but you can extend the retriever class to do this. But that's typically how we look at metadata operations. And that is the main difference between metadata and payload, actually. That payload you might want to embed, do other kinds of filtering and operations, while metadata are often second stage.
Thanks. We can take the audience questions.
Okay. Dhruv has a question. I like the Superbase ecosystem. Any issues you've seen with PG vector and prod? PG vector actually is very good till, I don't know, even like 10K, 50K vectors, and will serve you really well till all the way till like about 1,000 queries per second, actually. So you shouldn't really see, in most production systems by frequency, you shouldn't really start breaking. The only real downside of PG vector is that when it does start breaking, it's a very sudden fall in performance because it's actually an inverted, it's an IVF, it's an indexing system which does not really scale well with number of vectors or queries. So when it does start to fall off, you see that graph which will not scale linearly or degrade linearly. It just goes up to a certain point for your own data set and your characteristic and falls off a cliff. So typically, the moment you start hitting with a bottleneck with PG vector, you don't want to sit around and say, oh, can I improve PG vector metrics? No, you just say, okay, now is the time to remove vectors from Postgres and use a dedicated vector database. Does that answer your question? I have no way to tell that, but okay. More questions. Idea of cognitive search. Cognitive search is a Azure alternative for open search. That is what it means. It is not a specific idea. Search intent is to rank documents which are orthogonal, so VSS won't work. I assume VSS to mean vector search. Naive implementation is to do multiple search and rank them. I have Utkarsh has a question on if my search intent is to rank documents which are orthogonal. I don't know what orthogonal means. I'm sorry. In this context,
let me bring Utkarsh on the. He can ask you this question live. 1 second.
Sure, we'll wait while he comes on stage. Let me read the next few
Utkarsh
questions.
is live. Utkarsh live.
Yeah. Hey, hi, Niran. So my intent is that I have multiple documents and I want to retrieve documents which are not similar to each other, right? And let's say my intent is that, hey, show different, very simple example, show different type of products for this particular person, right? And when I say type, let's say the type is electronics, right? But then electronics, when I do this and when I do a very simple naive similarity search operation, it will rank the electronics the way it shows in the text of my embeddings, right? Now, if I want to implement a different logic here, which is to say the different type of products, different type of electronics should be headphones, should be gadgets, should be portable gaming devices, things like that. Now, is there a way I can capture that intent within one search instead of having to do it in a two-way search? So that's what I meant by orthogonal. So because the similarity search would reveal only
So you want the farthest vectors possible, not the nearest vectors possible, but bound within a search space.
Yeah, exactly.
Yeah, I don't think there is a. I don't think any vector database takes this use case very sincerely.
Okay.
That's, yeah. The way I would do this is perhaps to query a very large number of documents from a vector database. And since I get the embeddings anyway with my return, then do some sort of NumPy distance, which makes more sense in my context, so that I can get unique vectors which are far from each other.
Makes sense. So an additional question on top of that, with your experience, which DB would be better aligned to extending it for this type of use case, let's say, or simpler to work with? My goal here being that I don't want to do multiple level searches. So yeah.
Do you have some DB in your ecosystem already? Like that's the most obvious question.
Right now it's Pinecone.
Okay. No, I mean like do you have Postgres, Mongo, something like that?
Yeah, Postgres for the non embedding stuff.
Okay. So whatever is your limitations with Pinecone, you can just do that with PG Vector, and you will probably be able to go very, very far with that. And it will be basically cheaper than Pinecone by a lot. And probably be slightly more performant than Pinecone because we are in India. So for most dev, it will be easier. So yeah. And yeah, I actually don't have an answer to the main question which you have, which is, can you reduce the number of searches which you have to make? The sub question in your intent is which document, which vector base is good for doing a large scale. And we don't have benchmarks for that. In fact, I have not run a benchmark for that. The largest benchmark which I've run is for K equals to 100 on a million vector scale. And you might want to do larger than that. But for K equals to 100, I can say that both, I've tried PG vector quadrant, they both work really well.
All right, thanks. We'll discuss more with you offline. Yeah.
Sure. Okay, I believe that is answered. Next question. Embedding dimension across input data types, say documents versus code. I prefer instruct. Is vector lookup performance similar for code-based embedding as compared to text? The vector lookup performance is similar. Yes, because they are all dense embeddings, and there is no qualitative difference between the code embeddings and text embeddings. In fact, there is no qualitative difference between text and music embeddings. And I've seen some internal benchmarks from Quadrant, and we know that to be true. Now, on what rule of thumb for embedding dimensions across input data types? No, we don't know. The best embedding benchmark. In fact, let me. Yeah, I'll discuss embedding benchmarks, and I can answer that question there. We can leave that open. RAG using work for non-text data. Yes, it works for non-text data. In fact, it works really well. It works quite well for audio, and it works better than just doing MFCC and things like that. We have a use case. Oops. What's a typical pipeline for storing vectors for non-textual data, images, audio, etc. For storing vectors, the most common pipeline is you keep the raw binary or whatever is that JPEG or MP4 or whatever the text, sorry, MP3 audio, or WAV or whatever that format is, in some form of file storage system, and you have a lot of the metadata embedded with the point itself so that you can query it against the vector database, filter it as required. And the payload is quite often has the S3 path, for instance, let's say. And the payload has one more thing. I'm forgetting what we had for audio. I think we also had S3 path and some other information in the payload for filtering, like artifs and things like that. That is quite typical in terms of media pipeline.
Nirant, Ashish has asked a follow-up question, duration on this. What's the duration?
I lost context.
Maybe that's a different question. Okay, let's just take the next question and then go ahead.
Sure. Yeah. Saurav has a question on, we have a use case when number of documents are limited, assume 1 GB per meetings. Are open source options like PES good enough to tackle something like 10 QPS? PES with 10 QPS. Probably yes. 10 QPS should work for 1 GB of memory. Might be a little unwieldy in terms of how you want to orchestrate it, because you might have to deploy it, manage it, pickle it, all of that file. You will have to move the files. If you want to do any horizontal scaling or EC2, then that might be annoying. But otherwise, yes, 10 QPS PES should work. PG vector should work. Most things should work actually at 10 QPS, except maybe NumPy. What strategies does Pinecone etc. employ to efficiently update and maintain vector indexes in real time, especially in scenarios of the underlying dataset and those frequent changes or additions? Maybe we leave the real-time updation tricks question for later, because that is undergraduate course in itself. So I will try to do a 2-minute summary of that towards the end. Only question, another question. Is it a good idea to add transaction data like numeric data, for example, analytics and data for business dashboard? No, vector databases are garbage at that. Yeah, they're basically garbage at that. There's no real value of story. They're not good for analytics. Your Postgres with some tweaks will probably do better than I don't know, Mediate or Quadrant or than for all of the analytics use cases. How would you compare the RAG diagram versus using the Azure OpenAI service? Yeah, let's actually talk about RAG. I think all the remaining questions are about RAG. So let's take that up. So here are the open questions, right? What is the embedding you want to use? What are the top K docs we have? How do we ingest the document? We had a question around cost. So these are the 3 parts of that cost question. Is there anything which we can use from the user query side to improve the performance? And how can we evaluate the final answer? These are the rough range of questions which we care about. So for instance, Pranjal's question was around how do we select an embedding, which embedding matter? Ranking tips, how do we improve the selection of top tier documents, which is not something which has been asked directly, but indirectly. We had a question on cost, which is also around tracking. We'll talk about that briefly. We can do a lot of things to improve performance in terms of the correctness of the answer by expanding the user's query. Like, so for instance, if a user asks how many dogs are there in China, you could also rephrase that to say, what is the count of dogs in China in 2023? Which is the same intent of the question, which a LLM can rewrite for you. And the second question might give a more correct answer than the first one. And how do you evaluate the answers automatically? So all of these questions, I will try to give hints for them instead of trying to give direct answers or specific answers. So the idea will be, how can you make decisions instead of giving a ready-made answer? So let's start by making some choices. So here I have just picked a vector database, which I'm somewhat familiar with, which is Quadrant. For embedding, let's take that question. The meta question then becomes, how do you evaluate an embedding? And Pranjal had a question on that, is there a code versus text, is there a difference? And the answer is yes, there is obviously an but not in the vector lookup terms, not in the time. How do we evaluate this? So for instance, we might ask top 3 or top 5, top 10, whatever is that, whatever we care about. And we say, okay, the most relevant document, which was to this embedding or my question, was there or not, binary. That's one way to evaluate that. Reciprocal of the rank, let's say, for instance, the most relevant document was second, then your reciprocal rank is 1/2 or 0.5. If it was third, then 1/3, and so on, it goes till basically infinity. Discounted cumulative gain is a way of saying, again, a proxy of saying where is the most relevant document compared to some gold ranking of where it should have been. So the main difference between the first two and the third one is that to calculate the first two, you only need to know the most relevant document and where it is. And then for the second, you can just take a mean of that. It's a very famous metric called MRR, famously used by Yahoo Answers and then later for Answers. NDCG is a metric which a lot of modern search systems still use, including Algolia. So yeah, that's there. Very popular benchmark for selecting an embedding is called BEAR, which is benchmarking for information retrieval. You can look at all of these data sets which have a query and doc marked against it and see if your data set maps to that in some way. So for instance, on the rightmost, you might see biomedical queries in PubMed articles to all the way to, let's say, news articles. If you're working with social media, you might care more about tweet retrieval. If you have, let's say, corporate help desk kind of data set, you might care more about natural queries and entity retrievals. So mix of these. So you can reason about what might be a good embedding based on these specific data sets and the query and documents against which they're querying. The expansion of that, so for instance, this entire retrieval task, which we just looked at, is one square in the massive text embedding benchmark, which is quite obviously named massive. This also has some support for multilingual. For instance, the Amazon reviews, I think, have Spanish, English, French, German, and 2, 3 more languages, if I remember correctly. And so on. So all of them have non-English data. That is the intent. Okay, I will not go into the details of other tasks in the interest of time. But all of them need you to answer one question, which is I need the most relevant doc. In which case, one trick is you can use the LLM itself to find out the most relevant doc. And you can say, okay, given this doc in your prompt, tell me whether it is relevant to this question or not. The other is you can use that as a prompt. You can give a few examples of what you know to be relevant, 2 or 3 things, and then say based on this, can you grade it? And there's a very common grading trick which a lot of LLMs apply. And while it is frowned upon in academia for obvious reasons, there is no reason why you cannot use this to bootstrap your data and to get a qualitative sense of how this is behaving. And you can always verify the results manually. And verification is quite often anywhere between 3 and 5 times as much faster than actually tagging something. So it saves you a lot of time, even if you just move from tagging to verification. I will talk about ranking improvements. Most time we have about 7 minutes. Let's um, let's park this for now. That's too much to say. I will let's talk about this. Let's spend 2 minutes on this and then we'll come to questions. Um, the most common improvement, which I think everybody here should be familiar with, is that we can chunk things, uh, and we can use that to select documents, very obvious. We can add a re-ranker after the vector database, which improves performance, but at the cost of latency. A re-ranker or cross-encoder, including a very popular implementation from Cohere, works on the idea that if you have some top tier documents, it's able to reorder them because it has both the query and the context, and it is specifically trained on that. It has separate question encoder and a separate document encoder, so it's able to put them in context and re-rank them based on that. I have tried the Cohere re-ranker. It's terrible if you are working with documents which are 1 or 2 sentences, but if you're working with sentences which are about 5 to 10 sentences or larger, in your top 10, and the query is a sentence or so, which is what most humans do, then it's pretty good. Another trick is what Prank had asked earlier, which is how can you do a hybrid search? So this is, sorry, one way to do a hybrid search would be to first retrieve some top K, which is let's say some top 1,000 documents, and then pull out their embeddings from the vector database, and then re-rank them and then answer that. This does not really always add latency and is more often a method to improve your scaling than anything else. So for instance, if you are, let's say, a large insurer in Europe and you're working with 10 million documents every quarter, you would want a system like this so that you can filter on, let's say, a date or something like that for the documents, and just take those IDs, pull their vectors, and then do some take those vectors from the vector database just to pull vectors. That's the entire use case which vector database does there instead of similarity search, and then pass that to a re-ranker and pass that to LLM. This is a real example from a consulting client which I had in insurance. Using LLMs to evaluate systems. So the most important part in the screen is the one on the left, which is all the parameters which a retrieval augmented generation system actually you can tweak to improve performance, change cost. Everything which you really care about is on the left. The number of questions, which is on the obviously in eval side. The chunk size, this is the number of tokens. Chunk overlap, again, a number of tokens. The LLM, how do you split, like how do you create the chunk? What is the method for that? The embedding algorithm, the retriever, in addition to cosine search, you can use Euclidean search and things like that. Your top key, which is 3, 4, or whatever number, and the prompt itself, which obviously adds to the cost because these are also LLM tokens. Yeah. Challenges, utilization, solution. Yeah. This is also something which is spoken about in detail. Yeah, I think I will pause here for questions. And
Yeah,
How are the various books?
we have like 5 minutes for questions to Nirant. So please feel free to ask them. Ashish, can you type out your question?
Or ask orally, both are fine.
Yeah, okay. You want me to bring Ashish on? Let me see.
Yeah, we can.
Ashish, could you also introduce yourself?
Yeah, hi, I'm Ashish. I'm in academia working on biology and medicine, applications of AI to biology and medicine. My quick question was, in that diagram, right, the flow that we see, you write some code for BV8 or quadrant for chunking. How do you wire all of this? Is LangChain the kind of glue to wire all these together?
Yes, LangChain or Llama. Those two,
Or Llama Index? Okay.
Yeah,
Okay.
yeah. For question answering
And
systems in particular, I've had better luck with Llama Index than LangChain for a bunch of design, like library design reasons. But again, up to your use case. I think the most beginners, I think LangChain is as accessible as Llama Index, and there's no real difference.
And the other quick question was, 3 days back, Azure released an OpenAI service which has support for asking questions like ChatGPT to your own data. So rolling up your own solution using chunking and generating embeddings and storing it in the DB and wiring it to fetching the top K and all that. That compared to, like, have you had a chance to try that? Like, how would you compare the two? Like,
So
if you
that
have
is not publicly available yet, so it's not generally available. But we know from an outline that it will, like most things Azure, it will tie more deeply into the Azure ecosystem, which depending what you want to do may or may not be a good thing. I've been pro open source as long as the cost of maintenance is not very high. And open source also gives you the flexibility that you can fix things so if you so choose to. Azure has been known to, like, especially for the new services, have been in like the Azure AI cloud in particular, has some very interesting security issues, right? I mean, Microsoft is by far the worst security despite their marketing. Uh, and then they go ahead and sell that as Microsoft security solutions. But okay, coming back to point, there are a lot of security issues, including things like in the Jupyter Notebook versions, you could just query data which you were not authorized to. So if you expose that notebook to public, like the public could query your entire company, for instance. Access privilege is a very common security issue which these clouds often run into. And obviously cost is another reason why you wouldn't want to start with that immediately. Like in most cases, to be honest, I don't have a strong case against Azure. They might probably be better at this. Yeah, does that answer
Thank
your
you.
question?
Thank you for this great talk.
Okay.
Yeah, we have one more minute. Actually, we are on time. I guess, but is there any one last question you want to pick up from the Q&A box?
We can take something. Chunking tips. I'm sorry, I couldn't cover that.
We'll have a separate session on that. Maybe.
Yeah, I'm just going through all the questions. Vector databases internals. I don't think I can touch that. Basically finding value of a particular parameter inside multiple tables inside a PDF. LangChain, Llama Index. There's a question on how to find a specific parameter or search inside tables inside a PDF. That's a PDF parsing issue more than and that's an ingestion issue. Like how do we ingest the document issue more than absolutely anything else. Not really sure if your data going inside a system is bad. I don't think we can improve that by a lot, to be honest. What else is there? Yeah, I think that's the bulk of the questions.
All right. Thanks, Nirant, for this. I know you got to run in a couple of minutes, so please feel free to hang out. And if people can ask you questions on the chat, and then if you want, you can respond them back. I would like to now introduce Ayush. Ayush, are you there? Can you come on stage?
Hey,
So thank
Prank. No.
So folks who just joined us late, Ayush is down with viral fever and he's taken the effort to do this so that, all of you are taking out the time can attend this. So thank you, Ayush, for doing this. Ayush is the founder of Portkey, a serial entrepreneur. And Ayush, maybe you can introduce yourself and Portkey. I think that'll be best. So, yeah.
Great. Thanks, Frank. Amazing talk, Nirant, and really enjoyed it. Uh, Hey folks, pardon for my voice. I know it's a little bit too heavy and I'll be coughing a lot in between. So apologies for that in advance. So I am Ayush. I, along with Rohit, recently started working on this company called Portkey. What we are doing is building an LLM ops stack. Okay, 1 second. I'll just also open the Q&A and the site. Right. So we're building Portkey, wherein we are trying to build tools which helps you productionize your LLM apps. And we previously having built, me and Rohit, papertype.ai, which we started building in around January 2021. Early adopters of LLM scaled it to 400,000 plus users. All of the experiences, learnings that we have had, we realize, hey, there is a need. And as OpenAI, GPT, or LLMs in general have become so much more popular now, to an extent, like they are a commodity. They're going to be a commodity. Every digital app, to an extent, will be using either open source or proprietary or any other LLM. Uh, it is important that all the ecosystem around it, that all the things that we learned while we scaled an LLM app, there is a need that somebody can quickly plug and play and just focus on the business use cases. So that was the idea behind Portkey. Now, without taking much of your time, I'll quickly start my presentation. 1 second. I think I'll need to restart my this first time. Sorry about this, guys. 1 second. I'll just rejoin this call.
All right. So folks, while Ayush rejoins the call, I should let you know that next week we are planning a webinar around the same time, 4 o'clock to 6 o'clock. It's going to be a hybrid webinar, which is webinar we'll have at the Axel office. So for those of you who don't know, I'm from Axel. We are an early stage VC firm, and actually we are a multi-stage VC firm now. And so the webinar will be webinar plus meetup is going to happen together. So I'm just finishing one small thing. So next week, we are going to do this particular webinar. I'll be circulating this. You should be able to register for this webinar. So Llama Index. So Ravi is going to talk about Llama Index. And then Sandeep from Hashnode, they have built a search engine kind of solution using Anthropic and ChatGPT, and he's going to talk about that. So yeah, sorry, go ahead, Ayush. We'll circulate the link for the event towards the end. So.
Okay. Apologies for that. Yeah, using another machine, didn't realize I've been given permissions yet. I hope you were able to see my screen.
Yes. Yeah.
Great. So today will be like a fairly small, quick presentation about our learnings. Things that we see or we learned while you build a LLM app, what does it take to from the stage of POC to pushing it out into production and really scaling it up, right? So these are those learnings, just trying to put it all together. About me, currently building Portkey, previously worked on PepperType AI, PubNinja, EMEA Worldwide. Been with early stage startups, have written a lot of production code. They have built apps which have more than 20 million daily active users, LLM apps with 400K plus users. So yeah, that's me. This is just a summary or like a quick overview. Like under these categories, we'll deep dive that, output validations, rate limiting, latency, observability, model management, data privacy, cost optimization, DDoS. These are the certain categories of areas there. You will have to do something, or as you scale up your application in production, one or all of these problems will start to come in, which you will have to address, right? And starting with the first one, output validations, I think this is a very common problem, of course, and to an extent, Nirant also talked about solving this or solving the hallucination problems using your RAG pipelines. But essentially, the problem is it is difficult to guarantee a certain quality of format or output, either the quality or the output, right? For example, you want an LLM to always return a JSON, right? It is difficult to really guarantee that. A couple of solutions that we could do is either we write our own schema validation, could be like a GUI or something like that in Node. A very popular library, I think, which we have used and does seem very promising is guardrails. We'll show you a code snippet or what exactly is guardrails and how you can use this to ensure your validation of output schemas. Feedback loops does help, right? If in your workflow you can build a way where you can take the feedback from the end user on the quality of output, it does help. Maybe that using that feedback you can continue to fine tune your prompts and maybe fine tune your other parameters. RAGs can help minimize hallucinations. I think Niran talked about it in depth, and we all know that if you reduce the context or ask the LLM to answer from a given context, it does help, at least in the hallucination part. Use models to re-rank your results. Maybe if you're getting multiple results, you want to use Cohere re-rank or some other models to essentially see that, how can I, or which of the outputs it does make more sense or which is more closer to the expected output. And the last is using LLMs to validate outputs. This is essentially like a framework which there's an open there's a library for it called evals, which is done by OpenAI. Essentially, yeah. So OpenAI evals is basically this, where you use the LLMs to predict or to evaluate the output of the prompt, right? You can check out the GitHub repository. It's OpenAI /eval. So we have done a blog on this. This image is actually from one of our blogs explaining what exactly is OpenAI evals and how do you use them. So essentially, you have an input prompt. You send it to a LLM, you get an output, then you use that output and send it to a evaluation prompt, right? Embed it into an evaluation and then ask, very straightforward questions. Hey, does this correctly answer the question or not, right? And use your evaluation prompt as a criteria to understand, is the output good enough or not, right? Evaluation types could be reasoning, or classify, or first classify, then reason, or just classification. This is a few examples how you can work on improving your output. Other is this, quick spec from guardrails. Definitely should check it out. It's essentially like a Rail specification that you write to specify the structure and type of information, and then it wraps around your API call to validate and correct the outputs, right? So yeah, these are the few things in the output validations. Next is rate limiting. I think I'm sure everyone of us building with LLMs have seen this, especially OpenAI or GPT-4, that rate limiting happens quite often as you start to scale up. 429 is a new error code in your Sentry, a lot of 429s. Now, the solutions could be that, you can do an app-based rate limiting, that the entire application that you have, you rate limit that, which might not be very ideal because could be a certain set of users who are, using it, I would say within the limits, will also be impacted because of certain users who are, using it more than you would want them to. So, but you can try that, depends on the use case. Another is you can do rate limiting, but on the segment of a user or certain, properties of that user that you've defined. Like, for example, OpenAI would have different rate limits for their free users and certain different for their paid users, right? Then what you can do, this is like a basic thing. Next level thing you could do is you can do a load balancing on your multiple models. Load balancing multiple models. It could be maybe if, let's say, GPT-4 with a higher context does not work, move it to GPT-4 with a lower context, or maybe even a GPT 3.5. And you can also load balance your this thing if you have, let's say, multiple API keys from OpenAI, right? So your API key would be rate limited, but if you have multiple accounts with multiple API keys, why not load balance between them? This is like a hack, which essentially will get you a higher rate limit. I think I've written some pseudo code, some kind of a code, which, yeah, this is a user-based rate limiting where you can see free user rate limiter. I'm doing like certain max number of requests and premium user rate limit. And then you define your rate limiter and use it, attach these rate limiters to your, any endpoint. For example, your /API/LLM, you put the speed limiter in between, right? And sorry. Quick example how you can do rate limiting per user or per segment. This is an example of, again, like these are very, very like pseudo codes that I could do very quickly. Nothing, or I wouldn't say just copy paste them into production, use them as it is. But just to give an idea, I've defined, let's say, engines like GPT-4, GPT 3.5, given their endpoints, etc. Now, what I'm trying to do is, hey, if the first one returns an error, I'm doing for all the engines, loop over them. If get 200, well, good enough. If you don't have 200, maybe switch to another model which has a higher rate of success. So this is how you can build a very vanilla fallback. And all of this can obviously go into a config. You can switch only if you get a 429, or only if you get a 500, or if you get a 429, go to another model. If you get a 500, maybe you want to retry. So you can build a very comprehensive config management around this to help you with load balancing and also fallbacks. Right. Next problem, of course, is latency. Compared to your generic APIs, simple read-write kind of APIs, LLMs are slow. You do need a beautiful loader on your UI. You have to work on that UX to an extent, but there are certain things that you can do to speed up the process. One is implement streaming, of course, if supported, right? If you're using OpenAI models, strongly would recommend, if you're doing text, that implement streaming. It does improve the experience quite a lot. Implement caching, again, and I'll talk about semantic caching in detail later, but when we tried, or when we look at our data, we see 2 to 3% results do get cached, which is if you're doing a very simple cache, right? You, for the same incoming body, return the exact same response. That does work like 2 to 3% of the times on an average. But if you do semantic caching, we've seen it work like up to 20%, which is like a lot a lot of cost and a lot of requests saved to LLMs. Of course, 20% improvement in your performance overall. So yeah, if you can implement caching, and again, for latency, also build fallbacks to a faster model, right? This is a quick overview or a high level diagram of how a semantic cache could work. Like you have a, let's say, handler for your main application, and if you are saying, okay, I want to cache this request, maybe have another cache handler, then you have a simple key value store which can be used for simple caching. Now, when I say simple caching, I mean exactly same request. There is no change at all. And the key for that request could be, let's say, some sort of a hash of your request headers and request body. You take all of them, stringify them, create a key. Now, this key, if you have the exact same key present in your KV or present in your Redis or whichever mem cache you're using, but you have the exact same key returned from that. That's your simple cache. Even in case of semantic cache, if let's say you have implemented a semantic cache, even in that case, would recommend that you first check for the simple cache. If even you are looking for a semantic result, but you see that request is exactly same, then why not just return from a simple cache KV store rather than this. Again, now if you see, okay, a semantic cache, and what you would do. Oh shit, sorry. Where did it go? Yeah. you have the semantic caching on, you would look at your vector store, and if it is, you have stored all your embeddings, and if you see your search has a result above a certain threshold, now that this threshold could be 95 or 96, it depends on your use cases, would require a little bit of experimentation to understand what is that particular threshold that works for you. But if you're able to get that, then implementing semantic cache could help you up to like 20% or even more requests to be cached. We can talk a lot more about semantic caching in the end, and I would also love to give you a demo of how it is working in production through Bootki. And yeah, I think that's about latency. Sorry, I'm not looking at the Q&A. Is there any questions so far?
Yeah, there are one or two questions. So one is there any way to do this with existing framework like Hystrix? That is one question. For all circuit breaker use cases, I guess the same person asking these two questions. Yeah.
Exactly what with framework like Hystrix, are you referring to load balancing or something else?
Yeah, I think the person who's asked this question, can you please clarify this question?
Maybe what I can do is just have a Q&A towards the end.
Yeah, that makes sense.
Okay. I'll just take all the Q&As. The small presentation should be over in the next 5-10 minutes. Okay. Next is observability, and this is one of the learnings has been for me also as an engineer, and not specific to LLM or anything. It's just that when you think about logs, when you're starting a new project, you feel care logs and all, they'll figure it out later, right? Let's just build it out and see how it is working. And I think building multiple projects, I've realized that, hey, this is something that you can't look at it post you have certain users. It has to be baked into your V1. You have to have certain kind of logs, some observability around your application, and you can't fix what you don't know, right? So once you get the traffic, that's not when you put logs, or that's not when you set up your Sentry alerting monitoring. It has to go with the V1, right? And that's been my learning in general. When it comes to observability around LLMs, you could use Datadog Sentry, but there is not really a good support. Plus, they're expensive. Now, basically, in LLM, Sentry did did made life certain. I don't remember, but I think a month back they did launched a new class where you could use that, and they would to an extent be able to understand if this is an AI call or not, and just group them separately. But that's about it. Nothing else. And yeah, other way is you could do custom monitoring layer using ELK or Grafana. It's again very expensive, and also you would need one or two resources who are dedicatedly working on managing this if you're doing it at scale, right? It's not a very good out-of-the-box solutions available, but you could make use of Datadog to an extent. And this is how I reckon you would do your set it up in Datadog. You would have your custom functions to calculate cost. You would have your custom functions to calculate tokens, etc., response times, and then for each request, if you want to tag that request along to a user or along with the organization, if you have multi-tenant system, along with the tenant you want to filter, it is a pain to send all of those data to Datadog and create. And once you send this, then you have to create your custom views on the Datadog UI side, right? Time-taking process, and if you decide to change your this thing to another model, move from OpenAI to an open source model, or maybe a Cohere model, all of this has to be done again, right, from scratch, because the structures are different, cost calculations are different, etc. Excuse me. But right, that is one way of doing it, and I would strongly recommend that once you go to production, have your logs and everything set up well. Next is model management, as I think this is one problem that was very common for us at PepperType. We had I think 60, 70 plus prompts running in production, and it was very hard for, let's say, if now the problem is if we have to move all of them from DaVinci to, let's say, GPT 3.5, like how do I really push this out confidently, right? Whatever working in this, the same prompt would work in another model or not. Also very hard to your prompt engineers or your product managers in the company, right? They would want to tweak something. They would want to see, okay, if I change this prompt and update this prompt, how do I really see the output, right? How do you really map, okay, what prompt got good feedback, if you have, let's say, feedback loop also set up. Very hard to do all of those things, and we ended up building like 20 plus retool apps, one for prompt engineers, product managers, analytics, just to see, okay, they can push something, they can tweak something in the retool app, and the engineering team wouldn't have to really make a deployment. Time taking process, but this is something that we have to build, just to, otherwise it was too chaotic to manage the deployments, right? Imagine every other day, every day the prompt engineers would want to change something or update their prompts, maybe to an extent that they want to add another variable or remove a variable. So you're also not just changing the prompt, but also the template style of that, of that prompt. So it's important that once you're in production, have like a robust config management system of sorts, where you have like S3 you can use for your archiving, for your versioning essentially. Then you put everything in Redis with the template. It could be like a RDS of sort, which is a persistent store. You have everything in your your template variables, etc., etc. Cache all of this in Redis so that it's much faster, and then use it from your app. Maybe have like a retool apps on side which updates your RDS, or if you're updating a new prompt, then it updates the RDS, creates an archive, and put it in S3 for your future audits, etc. But yes, this is what we had to do, or it became like a bottleneck for us to move faster or experiment faster. Last is data privacy. You don't have a DPA signed with OpenAI, and it is hard to restrict users putting PII in the prompts. There are two solutions to it. What we did was like a simple redaction engine. Like you create a lambda, parse your input prompt through that lambda, and there could be like an advanced redaction engine, which is a customer fine-tuned model that finds this out and redacts those PII informations. I think this is a quick example of like a simple redactor. You redact emails, some regex for redact phone numbers. Then you create another wrapper around all of these, pass in the text, let it replace, and then what is the final replaced version is then sent to your LLMs, right? So this is again depends on what kind of use cases you have. You may or you may not face this problem, but for us, yes, it was important that we start redacting these user informations from to save them from going to the LLM providers, right? Then comes cost optimization. Yes, I mean they do bubble up very quickly once the scale starts to come in, and few things. Of course, use Azure credits until the last. Caching is important. And the other important thing is, find the right model for your use case. You may not need, GPT-4 or even 3.5. You may, are very good with the 13B model or any other open source model, right? Spend some time understanding which is the right model for your use case. Don't just, go ahead and use, GPT-4 just because it's, it has better benchmarks or it understands more context, etc. No, if your use case is something else, figure out a model which works for you and use that rather than any other model out there. So that's on the cost optimization. DDoS is a very interesting thing. Like I said, we started building it in January 21, the PepperType AI app, and we were mostly like copy.ai, where you could put some text and we would expand it or do something around it. A lot of options that we had. And we got a lot of attacks from Russia, Russian users, Russian IP addresses that they would just bombard our servers. A million requests coming within a minute or something. So that DDoS was important. It is important, and it's, I would say, not AI specific or anything or LLM. So this is generic. You could face DDoS attacks on any kind of application. So have like good rate limiting on your Nginx or any other web server Apache that you're using. Use Cloudflare, AWS. I'm a big fan of Cloudflare. I think you route your request through them. You don't have to really worry about DDoS or anything. Like they take like really good care of all those things. Yeah, like a simple config that you can put on your Nginx for rate limiting. Here I'm like doing 5 requests per second. Of course, you can change it. Whatever is your use case, etc. But having this is important. Running like a default server configuration on production is not really good. Do when you're defining your server block, do take care of these things as well, especially on production environment. See the overview and that what our learnings, etc. have been that on the left side, I have like a diagram of how things work in the deterministic world, right? So there are 3 core components in a deterministic world. You have an EC2, you have S3, and you have RDS. EC2 is doing all of your compute, etc. S3, you are storing your logs, archives, large files, etc. And RDS is for your transactional database, right? And everything in the last 2 decades has been built around it, right? Be it load balancing, be it queues, rate limiting, functions, auto scaling, security, observability, right? Everything, if you take AWS, they started with these 3, and then every other service or every other managed service is built around these 3 core components. You transport this to probabilistic world. You see an LLM is being replaced by an EC2. S3 is S3, but your RDS is now replaced by VectorDB. And in this ecosystem, a lot of these things are yet to be built. Like a lot of these tools which helps you, take care of certain of load balancing, etc. out of the box. They are yet to be built, or they are built. Maybe they are open source right now, or still a lot of new things every day we are seeing. But essentially, that's what our learning had been, that a lot of these things you have to take care of yourself or rely on keep updating yourself. There are things coming out every single day. Maybe there is a tool for caching which has come now, right, which is the GPT cache, etc. So yeah, a lot of these things you have to take care of yourself. A lot of these things are now starting to get available, so you should use them. I think, yeah, quick, what we are doing at Portkey is we are building LLM ops platform where we say, let us take care of your concerns about going to production. We'll do the observability, model management, monitoring, etc. You would be able to run your caching experiments, load balancing, fallbacks in a configure, and you just need to worry about refining your prompts and serving your users, or working mostly on your business logic, and all other components that we talked about. We're slowly building in Portkey. Some of this we have already built, and yeah, that's what we're trying to build with Portkey. Yeah, I think that's about it. Yeah.
Thank you, Ayush. Ayush, do you want the attendees to reach out to you or Portkey in some way? Like, is there some email ID if they want, how they connect with you? Or
Definitely. You can ping me, Rohit, either on LinkedIn, Twitter, or I'll just put in my email. Feel free to drop me an email.
Because there could be potential customers here as well. So that's why. Thanks for that talk, Ayush. Now there are, I think there's one question, and folks, if anybody has any specific question, please raise your hand. I think we have enough time. We can bring people on stage, else you can finish the call early. So Saurabh has mentioned something, which he says on the Q&A, does the organization have plans to make LLM faster? main concern making open source LLMs accessible plus scalable for CPU. So yeah.
So yeah, I'll just take that answer. Thanks, Saurabh. Uh, our plan is, at least as of now, is not to host or become like a hosting platform for LLMs, right? What we are essentially we are a middleware, or what the plan is that we want to be that middleware between your application and LLM that you're using. Now that LLM could be OpenAI, whatever, open source Hugging Face. And we, being that middleware, we want to allow you to, do all your optimizations here. How we would help in making your LLM calls faster is caching, right? We allow for simple cache, semantic cache. You could configure those parameters or tune those parameters in the port key layer. But as of now, not really focused on allowing or making LLMs faster, hosting on us or anything like that.
All right. Any other questions, folks? I guess no. Okay. Let's just wait for we have a bunch of questions just showed up. Okay. Would consider the usage of caching in chatbots where context could be different?
Yes, I mean, depends, right? If you are, let's say, building this chatbot over a knowledge base, then definitely it makes sense. Let's say, for example, the different users are asking similar questions, but they are pertaining to the same knowledge base, then it makes sense to cache those requests. For example, it could be like one of the use cases we have seen is a knowledge base of all your company policies, etc. Right? It is, let's say, a document across your Google Docs, your Notion, etc., where all of your knowledge base is, and you could potentially cache those requests if your users or the company users are asking for similar questions, right? For example, you have a chatbot which answers your company policies, like what is my leave policy, etc. Makes sense to use caching in those use cases. Any plans for image generation APIs? Yes, we are. So Putki works in two different modes. One is the reverse proxy mode, and then other is the model management mode. Reverse proxy, we even currently support everything, right? You would get your observability stack, retries, caching, everything out of the box for images. Reverse proxy is simply like one-line integration. You proxy your request through our servers and we do everything else. The other is model management. It's slightly more advanced use cases. There we are yet to support image generation, but if you want to, cache your request, etc., retries, etc., all of that is available. So I can say we do support image generation right now. But won't caching it expose to more data threats? Yes, yeah. This Ashish is a great question. Leakage is something which is a problem when it comes to semantic cache. Specifically, I think there was this question which which were asked 2 days back also. But yes, we are going to build some things around it, where we will essentially pass your data control policies as metadata. So we know that at least if a vector is or a particular embedding has an information which is only for a particular set of users, we don't return it to any other user, even though the cache is present. So that data leak, one way to solve, we are thinking of solving, is to enrich our metadata with, the user access rules or access policies. But you're right, semantic cache does expose a little bit of data leaking problems. Will be the port key would be able to suggest a right model for your customers in future? I mean, Jatin, definitely, with our experience, we can, I don't think we can automatically mode mein nahi hai, manually connect with us. We'll try to help you out, which is the right model for you. How the data privacy can be handled if you wish to use example, GPT-4 versus local LLMs. Data privacy can be handled, like one of the ways, like I showed you, was data redaction. Like you can have, let's say, a simple redaction engine or a much advanced action redaction engine, which is maybe a mini model running and trying to do the redaction. If you're using GPT-4, etc., if you're using like a local LLMs, and it's self-hosted, you are not really worried about it. I mean, it's up to you. You may not want to redact it, but it is important that you redact, because that LLMs, if it's keep learning, then it might return that API maybe as an output some way. So I would recommend doing it, but the mostly recommend doing it for less for local LLMs, more for GPT-4, etc.
Any more questions, folks? Okay, great. Thanks, Ayush, for doing the event, and while you were sick, so that's double thanks. So thanks all for joining. Pradeep, sorry, I think we'll maybe you can type out the question. We can answer that if you want. And folks, just a reminder. So this is the event which we are planning to do next week. This will be webinar talk as well as an offline meetup. I think I prefer offline always, but webinar allows us people from all parts of India to join in, and you have a bunch of people from Indonesia as well. In fact, for this particular talk, we had somebody from Chile send in a question. So we will be making the talk live, the registration link live by tomorrow. So please watch out for that. And we'll just take one last question, and then we'll end the chat. So the question is, Ayush.
Yeah. Will be okay, sorry. Here it is. You also mentioned fallbacks. How do you switch between different LLM providers? Interesting. Honestly, this is like one when we were building this. It was one of our problems as well, because your schemas are very different. You can't just forward an input and output, like same the request from OpenAI to Cohere. So internally, what we started building was something called Rubius, which was your interoperability, like no opinion, unopinionated framework, which transforms your request and response from the Rubius format is the common format, and it transforms. So that is what we built, and happy to say that we have also open sourced it. It is still in progress, but would love for you guys to check out and also contribute. So it's called Rubius. I will just put in the repository, but 1 second. Yeah. Yeah, this is a repository that we did use a lot of these components internally to provide fallbacks, etc. And this is open source. Yet, very early stages. We're still looking for contributors and adding a lot more things on our own. But this essentially is your unopinionated interoperability between different providers, and we are going to add the capability to cache, capability to do fallbacks, etc. within the Rubius itself. So if you want to build or do a POC between different models very, very quickly, how's the output of this, you can just plug in Rubius and yeah. So good question, and I think there was no short answer or a hack to do it. So we ended up building Rubius, which I feel, the feedback that we have gotten is so far that, it's quite useful, but let's see how it evolves.
All right. Once again, thank you. Folks, so I didn't, please email me at priyank@axel.com. I love AI and I want to make this a useful series of talks and meetups. And like all of you know, it's a little hard to get very experienced folks. Currently in India, I think in another one couple of months, we'll have lots more folks who have put their LLMs in production, and we'll be able to talk about real use cases. So In the meanwhile, if you think of any topics you think, and if a large number of folks request it, we will try to arrange for speakers for those. And also, if you have any good speakers, speakers like Ayush are hard to find, speakers like Nirant are hard to find. So please feel free to drop suggestions to us. We will try to arrange those discussions. And Axel is actively investing in startups in AI. So feel free to reach out again to any of us at the Axel team. So me, Anag, Tane, we are all in the call all the time, and feel free to reach out. Thanks a lot, everyone. Thank you for joining.
Thank you, Priyank, for hosting this. Had a great time. Thank you.
Thank you. Bye, guys.